Okay, in this lecture, I'm going to go over how to use Excel to compute the probabilities for a binomial probability distribution. For a binomial probability distribution, as you've already gone over, there's two possible outcomes. So it should be dichotomous data that you're dealing with. And so we're going to look at a particular set of dichotomous data for the men's basketball team. So I'm going to go ahead and share my screen here. Okay, and so what we've got right here is up in the left-hand corner, Coach Drew wants to score 80 or more points per game. This has occurred 68 out of 231 times in the past. So I could have made you go through and look through all this data and calculated. All that this is right here is I calculated the total number of successes out of the total number of past games. So I looked at all of the wonderful information, made a pivot table, and I said, okay, how many games did he score 80 or more points? I probably should have made you done it in here or something, but so 80 or more points. And what did I do here? Yeah, points. I did something. There's a points column. And so I calculated the number of games that he scored 80 or more points. And so that right there is a dichotomous variable because you either scored 80 or more or you didn't. So the goal is to score 80 or more points in 12 games. If the Baylor Bears play 30 games, what is the probability of every single possible outcome? Now, I'm not necessarily asking you to actually give me every single possible outcome, but we're about to show you how very simply you can. So I give you sheets like this so that way you can use them. Yes, there is this fun little thing right here. There is this information right here. But this is actually all set up for you to be able to use this over and over and over again with any possible situation. Okay, so first of all, what is considered a success? You're looking right here, scoring blank number of points in a given game or more. And so you're going to want to put in there what is considered a success. So the goal is to score blank number of points. So I'm going to do a hypothetical number just because I want you to do this by yourself and I don't want to just give you all the answers. So I'm going to do, let's say, 60 or more points in a given game. And let's see here. I'm actually going to see score. Here's what I'm going to do. Insert histogram. Bin width. Okay, so this is 37, 15, 7, and 2. Okay, so let's see here. 37, 15, what was this again? 7 and 2. So I'm going to equals sum. So now here's another way that I can do this, because I think that I have it off a little bit. Oh, I know why. Because I changed the. Okay, so scoring 60 or more points, not 80 or more points. I was like, it's coming out to the same numbers. Okay, so 60 or more points. So I'm going to come right here and just highlight the number of observations, 60 or more points. So that's 208 observations. Okay, so 208 observations. So I'm going to come right over here to binomial and I'm going to do probability of success at each trial. And so I'm going to do equals 208 divided by 231. Okay. Number of trials. So if the Bears play a total of 30 games, we're going to do 50 games for this one. So, but for yours, you're going to want to do 30 games. Desired number of successes. I'm going to want 40 successes because you should want 40 successes if your probability of winning is 90%. And then the mean or expected outcome. So in order to get the mean or expected outcome, all that you have to do is multiply the empirical probability by the number of trials. So multiply 0.9 by 50. And so we're going to do equals probability of success at each trial multiplied by the number of trials. And so I'm going to show you guys something fun and cool. This right over here is what a binomial probability distribution looks like. Oh, now I see where I put it all. See, this is all the games, and then it says, okay. Anyway, so the binomial probability of success at each trial. And so what you'll see right here is each one of these dots represents a trial. And so looking at this, you'll go all the way up to the top here, and this is trial 45. And it'll say, okay, 45, it'll say the probability of that very specific success, which is 0.01849. And then this is trial 46, trial 47, trial 48. So all of these are each individual trials, and the probability of success of success at each number of trials is listed there as well. So right here we have if we want to start trying to determine the probability of success at each individual trial using Excel, we can use the formula binomial.dist or binom.dist, and then we put this information right here. So what we have is we have X, you notice I have X, and then I have N, which is N, and then I've got P. So you put the information from right up here into this fun little formula. So we're going to do equals binom dot dist, and we're going to say, okay, what is the desired number of successes? So the desired number of successes is 40. What is the total number of trials, which is 50, and the probability of success at each trial, which is roughly 0.9. And then when we say false, what this does is this says, what is the probability of exactly 40 successes? Of us getting exactly 40 successes out of 50 trials. So that right there is going to give us 0.0148. So the probability of getting exactly 40 games where we win 60 or more points is going to be roughly 1.4%. Okay, given that the probability is true. So the next thing that we're going to do is we're going to say, what is the probability of having 40 or less games? 40 or less games. And so we're going to do pretty much the exact same thing, equals binom.dist. And we're going to have the number of successes, which is 40, the number of trials, which is 50, the number or the probability of success at each trial. And then instead of false, we're going to put in true. And you notice there it says true cumulative distribution. So what this does is it tells us what is the probability. Are you ready for this? What is the probability of 40, okay, or less? So all of these added up together. All of these added up together, which is very low because the probability of 40 is very low and the probability of 39, 38, these are all very low. And so when you add them all up together, it really doesn't add up to that much more. So that's kind of unique. However, if I wanted to change this and I said, okay, what is the probability of 45 trials? And it's going to change drastically because 45 is the most likely outcome. And so for 45 outcomes, so the probability of exactly 45 wins is roughly 18.5%. And then the probability of 45 or less wins is roughly 56.5%. And so it changes drastically because it adds up everything from here to the left, or from 45 or less. It adds up all of those together. And so we can leave it at 45. Why don't we just leave it at 45? That way, when we have the binom dot inverse and so on and so forth, it's a little bit easier. Okay, so I am 95% confident that out of n games, less than blank number of games will be successful. Okay, so we are going to do equals binom dot inverse. Okay, and we're going to do n. And then we're going to do p. And then R is saying, hey, this is how confident I want to be. So notice right here, it says returns the first value above R percentile. In other words, I am R% confident that less than blank observations will be successful. So we're going to put 95% or 0.95. Okay. And what we're going to say is I am 95% confident that less than 48 games will be successful. So that means I'm 95% confident if you add up all these probabilities together that the probability of success at each trial, that we're 95% confident that the probability will be 48 or less. Okay, so that's kind of how it works. So we're 95% confident that it's going to be somewhere between 48 and 0. Is another way to say it. Then binom.dist.range. What this does is says what's the probability of the probability being within, or sorry, what is the probability of the outcomes being within this range? Okay, so if I were to say what is the probability of winning between 35 to 45 games, we're going to do equals binom dot dist dot range. Then we're going to put n is the number of trials again. And I just like having it like this. So n, then p, and then x1, what we're going to do is 35. And then we're going to do 45. And that right there gives us the probability of it being between 35 to 45 games. And I also have this wonderful information down here. You could actually have, the cumulative probability, the probability of success at each individual trial, the number of successes, and all of this is calculated automatically by the information that you put in here. Now, the one thing that I really want you to realize or internalize, if you will, is that you can use this chart. You can use this tool for anything. You can literally bring this into your workplace and be like, oh, how do I do the binomial distribution again? Let me calculate the probability of success at every single possible trial. I set this up for you to be able to continue to use. And so I'm going to just randomly look at around my office and see if I have something that I can calculate the binomial probability distribution of. Okay, so I've got okay. I have a total of 6 balls here. And so there's a total of 6 balls, and one of them is red. The rest of them, it's kind of hard to see, but I have let's stop sharing my screen for a second. There we go. So we've got, oops, 6. And so if I were to look at these and I were to say, okay, what is the probability of me grabbing a red ball? And so you look at the empirical probability, and it is going to be 1 out of 6. And so if I just always take that 1 out of 6 and I replace it every single time, so the probability is always going to be 1 out of 6. And so I grab one and I just randomly grab one, and oh, it's yellow. Okay, oh, it's yellow again, and then yellow. Ooh, red. And so I just keep grabbing them and I keep replacing them, so on and so forth. And so I could do this. And so we're going to do this really quick. And we're going to change the probability. And so we're going to do equals 1 divided by 6. Okay. So the probability of success at each trial now is 16%. So what is considered a success? And a success is considered, what is it? Grabbing a red ball. Okay. So let's set the number of trials. Let's say that we're going to do this 200 times. And we want to know, we want to have, let's see here. First of all, I want to find, yeah, I want to grab it at least 40 times. I really want to grab a red ball 40 times out of, 40 times out of 200 trials. And so we come down here again and we do the mean or expected outcome. So the mean or expected outcome is going to be equals the probability multiplied by the number of trials. So it's going to give us, this is the most likely outcome, 33.3. Okay, or 33. If you go up at the top, it's going to say 33. So next, coming down here, we do the same exact thing over and over again. What is the probability of 40? Exactly 40 balls being chosen. So we're going to do equals binom dot dist. We're going to do number S, number of successes, so 40. Then the number of trials, which is 200. And then the probability of success each trial. And then false for saying, false for saying I want the exact number. So the probability of exactly that is 3.28% or 3.3%. Okay. Binom.dist. So for 40 or less, so we're going to do the exact same thing, binom.dist. Then we'll do x, n, p, and then true. And this gives us 40 or less. So the probability of 40 or less is going to be 91%, or 0.91 technically is the probability. So then we're going to do equals binom dot inverse. The number of trials is 40, or sorry, is 200. The probability of success, and then we want to be, let's say, 90% confident. So we're going to put 0.9. And so we are 90% confident that 40 or less red balls will be chosen. We are 95% confident that 40 or less red balls will be chosen. And then let's see here. Binom equals binom dot dist dot range, and say I'm concerned about, hey, what is the range between let's say 35 to 45. So let's do 35. Oh, trials. Probability, and I'm just making up these numbers, the 35 to 40. So, or 35 to 45. And it doesn't have to be a range of 10. So maybe we should just do 35 to 40. What is the probability of it being within the range? Or if you're like, hey, I want to go around 40 and I want to do 38 to 42, you can put whatever numbers in there that you want. And so 16.8% or 0.168. And so that's how you would do it. And once again, you can see, every single time that you change it. So if this probability were to change, and we wanted to say, hey, what's the probability of grabbing a yellow ball? Well, it changes completely. So the entire distribution shifts over, and the probable outcomes are going to be on the other side. And so, depending on what your desired success is, because right here, then the desired success, that would be grabbing a yellow ball instead of a red ball. And so everything will change based on the way that you do everything. If you change it to do just 100 trials, it changes that as well, because only 100 trials will be listed. And once again, this is something that I built. You're not going to see this anywhere else. It's a tool that I built for you to be able to do this. So yeah, that's how you go about doing this, and hopefully this is a beneficial exercise and a tool that you'll be able to use in your exam and in the future.